back, guys. Today we're going to do a follow-up video on the Steve Morris build. During that video we were torque testing Steve's drive shaft and our Torque-anator broke. So I was just going to follow up today with a video show exactly how the machine's designed and what broke while we were doing that and how we're going to fix it. Also, we had quite a few questions on the original video, so we're going to address some of those questions today. Mel?
Hi guys, this is Mel. First question, actually I shouldn't really say it was a question. Numerous people made many comments about the PPE and that we didn't use it. I'm here today to show you, yes, we do in fact wear safety glasses. We have N95 respirators for while we're cutting the carbon fibers so we don't breathe the carbon fiber dust. And we have respirators for while we're doing all the acetone and all that stuff. So we do have this all available. We do use it. The point of the video, we were just doing one simple drive shaft. Maybe it was our mistake. Maybe we really should have worn all of this stuff. Looking back in hindsight, I guess. But really, it was just a really quick video. We were doing a lot of talking. It's honestly not very easy to talk with respirators and masks on. So we just wanted to let you all know, yes, we are safe. We do use the products that are required for our job and safety and everything else. We do appreciate everybody bringing it to our concern and to our attention, I suppose. But we will try to be mindful of it in future videos. I just want everybody to know we are safe. On top of all of that, I really don't want lung cancer or any other health issues that may arise from using the products that we do. So wanted to address that very quickly before we go into here. So I'm gonna turn it back over to Shane so he can explain all of the technical stuff and what happened when the torque machine, I shouldn't say exploded, when the torque machine sheared the bolts. And back to you.
So what we've got, guys, I designed this machine. A good friend of mine, Kevin Powell, helped me. He's an engineer. He helped me with design of this machine. So we have created a number of shear points on this machine. It's capable of probably up to 4,500 foot-pounds. So of course that was the first drive shaft that we had torqued that far. Typically we torque about 3,000 foot-pounds. Steve's we torqued to 4,000 and the bolts sheared, which is exactly what they were supposed to do, but unfortunately they sheared a little bit too soon. Obviously we want the machine to be able to go to its full capability and the shear points be at that torque level. But I'll show you quick exactly what we have. So we have a hookup that I've designed that goes onto the tailstock, is just held again with a bolt, which is another shear point. This was a grade 8. This plate is our lock plate, which slides onto our hookup and is bolted with 4 bolts on the back, and then of course slides on here, and that's what holds our drive shaft in place at this end. These are the 4 bolts that sheared off. You can see the 4 bolts right there, what's left of them. Those were a grade 5 bolt out of my bolt bin. So what we're gonna do is we're gonna reassemble this machine and we're gonna put some grade 8 bolts in here and we're going to try it. I'm pretty certain that's going to correct the problem. One question we had, or I shouldn't say a question, but a suggestion was that we use a hydraulic / something table. We did originally start with the idea of a hydraulic system. Back to my good friend Kevin, the engineer. After discussing with him different options, the problem with hydraulic is, as most people know, hydraulic is very dangerous. Hydraulic is under considerably high PSI. So if you have a hose failure, if you have a failure, it can be dangerous to anyone around it. Also, hydraulic requires a lot more pieces. You've got to have some sort of hydraulic power distribution, which requires a tank, a motor. So Kevin came up with the idea to use just standard shop air. We have 150 PSI here, and we run a 4-inch cylinder to twist these drive shafts. If we ever have a hose fail, all we have is an air hose flopping around and we can turn off the air. We don't have to worry about anything dangerous. We also don't have hydraulic fluid all over the shop but that's why we chose to go with air. This old machine was actually my very first machine that I ever purchased. I actually originally built drive shafts in this lathe, which I think came off of a ship in the bottom of the ocean somewhere long time ago. We pulled it out from the corner of the building, we ripped the machine apart, and we started our assembly of the Torque-anator. The other nice thing about the way we designed this machine, like I said, with the shear points, the machine did exactly what it was supposed to do. The bolts sheared, the drive shaft stayed in the machine, nothing ever came out. And that was our goal, is if something is gonna go, where's it gonna go, and still keep all of us safe. But like I said, I just want to give everybody a heads up, like I said, a little bit how the machine worked, and please, if you haven't seen it, check out our full-length video. I think Liz is gonna put a link in the video. Like I said, please check it out. It's a pretty cool video. I'd also like to shout out, I had mentioned my good friend Kevin Powell. Kevin has a podcast called On the Trail with Kevin and Scott. Another very informative site. You know, check it out. Kevin is constantly doing some good information in the automotive world, mostly with Jeeps and off-road. Kevin loves to answer questions. Please check him out. Mel, do you have any more questions?
Yeah, there was a question from somebody that asked if twisting the carbon fiber makes it weaker. Does it have any impact on the actual drive shaft when you torque test these? And as you saw, it went to like 10 or 12 degrees of twist. So the customer was asking, does twisting the carbon fiber actually make it weaker or compromise it in any way?
It's actually a great question. Fortunately, that's one of the keys to carbon fiber. Carbon fiber is made to twist.
To flex.
Made to flex. You can actually buy carbon fiber in different flexes. Some race teams may have 3 or 4 drive shafts in their trailer with different types of weave, and they can actually tune their car with different twists in the tube. But as far as damage in the drive shaft, no. The way carbon fiber is, the bond is either good or it's not. So when we test up and we have a good bond, according to our tubing manufacturer, that drive shaft could sit there all day long at 4,000 foot-pounds, as long as my machine will hold it. It can sit there all day long, and no, it doesn't sacrifice any of the components, anything at all. You also have to remember, when this drive shaft leaves here, most of these drive shafts are going into some seriously high horsepower, high torque cars, and they're doing this run after run after run. So what we do here generally is nothing compared to what they're going to do to the drive shaft. Like I said, the key to this machine, we're not testing components. All the components have been, all that testing and development has been done by the manufacturers.
I think you should maybe mention who is the manufacturer.
Yes, and I was going to.
Okay.
The manufacturers have done all the testing and development of all of these products. So basically, we just needed a way to ensure that when this drive shaft leaves our building, you know and have peace of mind that it's going to hold. You know, your car is not going to be the test mule for this. Speaking of manufacturers, the tubing itself, I think that was another question, right? Was
somebody asked if we make our own tubing, which we do not.
Which we do not. We don't make our tubing. Our tubing is made by Composite Driveline up in Wisconsin.
At Amaga Composites.
At Amaga Composites. It is actually, we went up to their facility and we walked through the entire process. And let me tell you, the carbon fiber building would take a facility of its own for us. Something that right now we're not ready to take on. But to add to that, that's how we got here. Composite Driveline, Amaga Composites, created this new carbon fiber driveline system. The old systems worked, but they don't work great. So they went to research and development to take their current composite materials and jump into the automotive world and offer a better product. They came to us looking for, they wanted a few really good builders throughout the country to take on this line, and we were chosen as one of them. So of course, that's why we're doing our part to make sure not only can we build their product, but we can build their product to their level of quality and test everything again before it goes out the door. So.
And you know, maybe that might be another idea for another video for another day, because we actually do have a sample that we take with us to events where our guy in the shop, Dave, has actually cut out a section of the carbon fiber tubing to show how exactly it's pressed and what we do. So we won't get too much in depth on Amalga composites, composite driveline. I mean, pretty much in our shop, it is Amalga / composite drivelines, bond yokes and tubing and 2024 flange adapters. We use all Sonics for our aluminum. We use all Niapco performance U-joints. We will absolutely never ever sacrifice the quality of our product to save money. Personally, we feel that the performance line of the Niapco U-joints is superior to anything else on the market, so that is the only thing that goes in our drive shafts. Again, probably another video for another day.
Yep.
Another question that we had that wasn't really quite worded this way, but maybe you could go into a little bit, is the safety feature of this machine. When you and Kevin were designing it and developing it, you created it so that bolts will shear, other things will happen versus the drive shaft breaking. Did you ever, I might have missed it when I was reading through notes, but did you ever mention that it only has a 4-inch movement?
Yeah, just quickly, but yeah, okay. Like I said, the cylinder we chose for this, mounted here off the back, is a 4-inch travel cylinder. There's really no need to travel any farther than that. Like I said, we're just testing the bonds. So even when these bolts sheared, that cylinder will only allow that drive shaft to travel, or that cylinder to travel 4 inches. It's not going to allow it to make complete rotation. Again, everything stays in the machine. And like I said, we've tested, because I think one person asked if this was the first drive shaft in the machine. No, we've tested quite a few in the short time that we've had this machine built. And like I said, typically we go up to probably about 3,000 foot-pounds. But me being the cocky person I am, I was like, well, this is Steve Morris shaft, and it's a 4-inch 155 wall, and I'm going to take it to...
With 1480 U-joints instead of 1350. I'm going to take
it to 140 PSI and 4,000 foot-pounds. And but like I said, at the same time, it allowed me to find out where my machine needed to be changed. So like I said, we're going to step it up to the grade 8 bolts and continue on from there. But yeah, the machine itself, like I said, does exactly what it's supposed to do. We've had a couple shafts that we saved from when we very first started. We were, of course, new at it. We did have a couple failures. We sent them off for analysis.
Some were our fault, some were at a point during the COVID whole thing. There were some very compromised 3M adhesives, and we happened to get a nice batch of them. So some were our fault, some were the actual bonding agents in the adhesive, which we can't control that part. But
so basically what it is, it comes down to one of two things. You're either going to have a chemical failure or you're going to have a contamination failure. And in the ones that we had analyzed, they cut them open, and one was contamination. So in other words, somebody didn't clean something well enough.
That was before I started.
Hence why Mel builds all the carbon fibers now. She won't let us touch them because we don't clean well enough. The other one was a chemical failure. We found out originally we had the carbon fiber assembly set up out here in the shop where it's not temperature controlled. So the glue we use is a 3M adhesive, very similar to what they use to put panels on the space shuttle. This stuff is very expensive, but it's NASA strong, I guess I should say. So the glue has to be stored at room temperature. We also found out, we didn't know beforehand, but there is a date code on every tube. And Mel and I got so excited, we ordered a large quantity of glue and didn't use it fast enough, so they had us check, and sure enough, we had some expired glue. So that glue, of course, got thrown away, which, like I tell Mel, well, shoot, I could have just put $100 bills in the garbage can and lit on fire, but cost of doing business. So now we buy our glue in smaller quantities. Again, that's why our carbon fiber is done in the clean room, temperature controlled, and since Miss Mel has taken over and we're doing everything up there. She is actually batting 1,000. She has no failures.
So let me ask you a question, because we had a little family emergency last week, so I wasn't here when you guys were actually testing Steve's carbon fiber and putting it in the balancer and assembling U-joints and all that stuff. So when that drive shaft let go and the loud bang, I saw your guys' reaction, but what was the thought in your brain?
About myself.
Oh. Okay.
And I have a feeling our wonderful filming girl,
our
Liz,
media girl,
was right there with me, since she was standing right next to it when it went. But like I said, we were all safe. Nothing came out.
That's a quick thing to bring up. Sorry, I know you were probably thinking something else, but let's say the machine didn't go. Maybe you should really quick touch what does happen if the carbon fiber drive shaft itself was actually going to break. We still would have all been safe, because you wouldn't have had aluminum pieces flying all over the place because of how carbon fiber is actually manufactured at the break points and what happens.
Okay, yeah, very good question, very good question. So one of the keys to carbon fiber is the safety of carbon fiber. So when you have a steel or aluminum drive shaft, they're metal. So when they come apart, who knows where they're going to go?
How much is going to tear off?
Is it going to come out in one piece? Is it going to come out in 1,000 pieces? So, you know, it may be joining you inside the car. Carbon fiber, when carbon fiber gets to a failure point, it's going to turn into basically a dust.
Sort of looks like broom, ends of a broom.
So now you don't have to worry about those metal parts coming through the floor, tearing up the underside of your car, maybe an expensive exhaust system. I mean, everyone knows how much stuff is underneath a car. So like I said, when you talk pros and cons of steel and aluminum to carbon fiber, obviously that is one of the biggest pros, is the safety of carbon fiber. And again, just like in our machine, if for whatever reason our bonds do hold and a carbon fiber tube comes apart, which I don't ever see happening, but if it does, it's going to look like a big dust bowl in here. But that was a great question. I'm glad you asked. On the hookup, like I said, when we have this in here, so as you can see, this plate slides over the back of this and 4 bolts hold it on. This bolt here is what's locking that drive shaft in. So when those bolts let go, it just allowed this piece to stay here, and that whole drive shaft went the 4-inch travel, and this flange was able to twist, hence why the drive shaft stayed in the machine. We didn't have to worry about it coming out, any of us getting injured. So like I said, I'm really excited that it did exactly what it was supposed to do. Again, everything we do, we look at, number one, at the safety. We want to do this for a long time. We want to make sure we put out a good product, but at the same time, we want to make sure we can be here every day and make it happen.
This video is getting pretty long. I hope we answered a bunch of questions that you had, that you asked. Please leave more questions. We appreciate the feedback from everybody, good or bad. Regardless, we appreciate feedback. And definitely like the questions. It helps us know what you guys are thinking, what you guys are wondering, helps us provide more videos, I guess. But we really just wanted to touch base on this one first off, because this is a very important machine. We do carbon fiber every day. We want to make sure that people know our machine is fixed, it's working, and answer questions. So if you don't have anything else, but
like I said, if you haven't seen the full video, please check it out. It was pretty cool.
Yeah.
A little sketch, but it was pretty cool. But definitely check out the whole video, and we really appreciate everybody watching.
Subscribing.
We've gained a ton of subscribers. Again, thank you. We appreciate it. We're new at this. We plan on adding a lot more. We want to do a lot of informative stuff. I think we're going to do our brand new balancer. Like I said, we'll create hopefully some good content that everybody loves.
And keep asking questions, because it lets us know what to film and what you guys want to see.
What you guys want to see. Again, thank you. And if you haven't, please, like, share, subscribe, and we'll be back soon. Thanks, guys.
Thanks.